G'day, thank you for joining me in the third and final in our series of videos about building and deploying a high availability cluster in Proxmox. In this video, we're going to complete the process by deploying two different servers, one as a container, and that's going to be running Pi-hole, and the other one will be a Home Assistant server. And both of them we will set up in high availability, and I'll show you how the machines migrate. So if you're interested in setting up Home Assistant as a high availability service, this is the video you want to watch. So now we're going to deploy a couple of machines, and we're going to configure each of those machines with high availability. So the two machines I'm going to deploy, one is a Pi-hole, which I use as a local network DNS server. I'll explain what that is when I get to that point. The other is Home Assistant, and we'll be using a scripting method to be able to do that within Proxmox. So the first thing we need to do is configure our networking. Now, for whatever reason, I don't really understand why, when Proxmox is deployed using the method that we are using, it doesn't deploy all the dependency applications it needs to fulfill this particular part of the process. So we actually have to install an application called if up down 2, and what that allows me to do is when I change the network configurations and hit apply changes, it actually applies the changes. I'll show you what I mean. So in my network configuration, what I need to do is change this setup so that no longer is it using the IP address directly on the network interface. We're going to put a layer in front of that. So how we do that is we go in here, we just copy this name here, then we delete these two settings here, hit OK. Now we go create LAN bridge, paste that into the bridged ports, and then put back in here 10.110.5/24. This is on node 1. Make sure you do the IP address for the correct node, 10.110.10.1. Hit create. Okay, great. Now I can hit apply configuration, but I do want to make one observation. Very important. Don't do what I've done more than once. Remove the IP address on our network interface card and then not create the bridge and then hit apply configuration, because what will happen is the device will disappear off the network. You actually have to go back to the laptop, open up the screen, log back into the terminal, and then manually recreate the network settings as you did right back when we first built the Debian install. So it's a bit of a pain in the neck. But anyway, we're not doing that. So we hit apply configuration. It takes a second, and that's done. Now we need to do the same thing on each of the other nodes. So rather than make you watch, I'll pause the video and come back once I've finished. So now that we've got our network all configured, I can see here if I go to each node, you can see I've got my network devices set up. So now what we need to do is download or make sure that our system is up to date with all of the templates. And so what we do is, if you look on my website, you will see I have provided this command. And all that does is updates the template library to make sure that it's all up to date. So now that we've got that set, what we can do is, it doesn't matter which machine, you can pick any of these. You can see there on node 3 I've already got a template loaded. But for this purpose we're going to use node 1. We go to templates, and because I'm most familiar with Debian, I'm going to use Debian. Now at the time of recording this video, I know that the script that I'm about to use to pull down Pi-hole doesn't work with Debian 11. I tried it the other day and it doesn't work, so we're going to use Debian 10. All right, we just hit OK. It doesn't take very long. I'm on a very fast network connection, so it only takes maybe 30 seconds. That's it, done. Great. All right, so now we've got our Debian install deployed. what we're going to do is build a machine with it. So we go from our node, hit create CT. I'm going to give this a node ID of 101. This will become obvious as to why I've done that in a little while. Pi-hole, give it a password. This is the root password that we use when we log into the machine after we finish building it. From the template, we select the only template that's available. If I had more templates available, they would appear in this list, but I've only got one. Now, one of the things with Pi-hole, it's very lightweight, so I don't need a very big disk. But this environment has got a reasonably high number of resources available, but I want to use those resources for other machines. So I'm going to go as conservative as I possibly can in terms of resource allocation. So 2 GB disk is all I need here, 1 core of CPU, and only 256 meg of RAM. I'm going to leave the swap disk the same size as it normally is. And then in network, we make sure we've got our bridge connection set up. We set our IP address 10.110.10. And I'm going to use 8 because it's the next one available in this network range. The gateway is 10.110.10.1, and we go next. We leave this as use host settings. That's not going to be any problem. We can change that later if we need to, but the whole point of this is that we're setting up a DNS server. Once we've done that, hit confirm and finish. And I'll pause the video until it's completed. All right, that's done. Didn't take very long, only took about maybe 30 seconds. So now our machine is built. You can see it is appearing here. Of course, it's not actually running, so my console is going to fail. Now I hit start, and because it's a container and a very lightweight container at that, it takes hardly any time at all. What's that? Maybe 4 seconds to boot up. So now that we've got the machine booted up, we can do our required settings. So the first thing we're going to do is go into root, and we do an upgrade and update. All right, now this won't take very long, but I won't make you watch it. I'll pause it until it's complete. All right, so now that's all done, we are going to install curl, because curl is required to download our Pi-hole repository. So that'll run off and do its thing. And I'll pause the video until it's completed. All right, and lastly, we're going to actually run our curl command to install Pi-hole. So I'll pause this video until I'm required to input some information. All right, so installing Pi-hole is pretty much follow the bouncing ball. I'm just going to use the defaults for the most part. Only thing I'm going to change is I'm going to use Cloudflare as my DNS provider. This is the block list, the blacklist, I should say. We will change this, or can change this, during our configuration. Like I say, one of the downsides of Pi-hole, if you're going to use it as an advertising blocker, is it can be quite intensive in terms of managing it. I'm not using IP6, so I'll turn that off. Yes, okay. We will use the admin interface on. Yes, on, show everything, and that's it. It's pretty much all we need to do for the installation. So the installation has completed, and we can see here the IP address. This is what I could use to open the interface. It's telling me here that I just go to this page, and I'll be able to open the admin interface. It's given me the option to use this password, but I'm going to change that, and I'll show you how to do that in my next step. So to change the password, we just issue this command. Again, this is on my website, and that way when we log in, we can use a password rather than remembering the one that's been generated by the web, by the installer. Like any other password, make sure it's complicated, but something you remember. All right, so that's that done. Now I can browse to my Pi-hole. There we are. and voila, log in. She's all up and going. Done. Now, a couple of points. On my website, I've shown or talked about the fact that you now need to configure your router to point to Pi-hole. Otherwise, there's no point having it, because you need to make sure that when anything that any computers or whatever get an IP address, they are directed to use this as the DNS provider rather than your traditional one, maybe Google or whatever. So that's a step that you need to do. Everyone's got different routers. I'm not going to describe how to do that. I'm using a Ubiquiti setup. It'll be very different for everyone else. But really the one thing that I want to show you now, and this will be the end of the video, is this DNS record. Now there's two parts to this, CNAME and DNS record. Really the only one we're really concerned about is DNS record. But what CNAME enables you to do is you can create an alias. So for example, if you have lots of services that use the same IP address, but they are called different things. So if you're using maybe Plex or even MQTT or something like that, where you know the same server is running lots of different services on it, then you might want to divide up those names, the CNAMEs, to be specific to each of those services. So you'd have, Plex, for example, would go in the domain here, plex.fitzsimmons.com.au, for example. That points back to Prox1 as an example. It's not, but that's just an example. I don't use CNAME because I don't really have services like that, but it's something that I can see value in. In my case, all I want to do is set up the domain names for each of my Prox servers, my Proxmox servers. So Prox1, make sure I've got it spelt correctly. Wrong address, 5 even. Try again. All right. So the advantage of doing this is it means that I'm never ever going to post this. I'm never going to make this browsable from the internet. It's going to be contained within my dedicated network, even to the point where it's not even browsable from the rest of my network. You've got to be within the management network that it's connected to in order to get access to it. So this just makes it easy for when I'm browsing that. I'm going to do the same for each of the servers, and I'll show you what happens. And the benefit is that because I have identified this domain name as the name for each of the Prox nodes, when you don't have the DNS setting configured, if you just browse, so for example, if I go to 6, this may not work because I've already been browsing to it. Leave. You will often get a certificate error. No, well, because I've already browsed to it, I'm not getting the certificate error. But now that I've configured these domains, just to show you what difference that makes, if I go into one of my nodes, so this is the node 1, if I paste that in there, and because I've set up my router to use Pi-hole, now it's logging in without a certificate error. So you can do that with any of your internal configuration services that have perhaps created a certificate, such as what Proxmox does, therefore eliminating the need to, for example, use a host file on your local machine. This is network wide, so whenever I go onto any other machine that is on the same network that can access the Proxmox servers, then I can just use my DNS settings. So there you go. Just some other quick things to show you. If you want to change your ad list, I've made a list in my web page where you can find out a lot more information about how to set ad lists, etc., to see what sort of ads are blocked on a network-wide scale, things like that. As I say, I don't really use Pi-hole for the purpose for which it was intended. I'm just using it as an easy way to build a local DNS. Okie doke. So now we've got Pi-hole all set up and running, and I'm happy with it. Now what I want to do is show you how to set up high availability and replication. So the first thing we need to do is to go onto our Pi-hole server, which is running currently on node 1. Then we go to replication, hit add, and then we decide which server we want to send this to. Now I'm going to set up 2 replication jobs, one for Prox2 and one for Prox3. But just some things you need to be aware of with replication. Obviously, the more frequently you do the replication, the more up-to-date the machine is going to be when and if it needs to come online as a result of a high availability changeover. However, the more often that you do the replication, then the more bandwidth it's going to use. So maybe not such a big deal if you've only got 2 or 3 servers running on your virtual environment. Given that we're in a home lab, that's probably not an unrealistic thing. You may not want to replicate everything anyway, but you need to be aware that because you're only using one network interface card on each of these laptops, you're going to use quite a bit of bandwidth when you do a replication, or potentially use a bit of bandwidth. So this may impact the availability of the virtual machines. Now that'll be very problematic, particularly for Home Assistant, because Home Assistant has quite a lot of network traffic. So you need to bear that in mind and maybe do some experimentation. Perhaps be willing to live with an update every 30 minutes, maybe every 2 hours, keeping in mind that if you're not using replication at the moment, you're pretty much at the mercy of the last snapshot that was done in Home Assistant last night. So maybe don't go too aggressive. Be just something to experiment with. But in my case, for this example, I'm going to use 15 minutes. You can also rate limit the bandwidth. This is something you would need to read up on. I don't know anything about this just at the moment. I'm not going to use it, so we'll just leave it as it is. Hit create, and then once it's created, we'll hit schedule now, and after about 30 seconds or so, the job will kick off, and then we'll see replication. There you go. As you can see, the job has started, and because this is a fairly small machine, it's only a couple of gig in terms of storage size, this probably only takes about 30 seconds to synchronize to the storage. So this won't take long at all to finish. And there you go. Oh, it's probably what, 25 seconds? There you go. It says 22.6 seconds. So we're going to do the same thing again. This time we'll do the replication to Prox3 and we'll hit create. I'm not going to make you watch this one synchronize. Now what we'll do is go and set up high availability. So how we do that is we go to data center. We go on high availability down here. We select add, and then we choose the machine that we want to monitor. You could put a note in here if you wish. You can change the status, whether you want it to be started or not. Hit add, and once the job has started, you see it's queued there at the moment. That means it's waiting to make sure that all is synchronized, and now it's started. So that means that if I was to disconnect the network on Prox1, then eventually what would happen within a few minutes, the machine, this machine here, would move to one of these other nodes. Now just a note while I'm here, when we first started talking about why it was that I installed Proxmox on 3 machines rather than 2, this is how the quorum works. You can see here that each of these machines has a vote. At the moment, Prox3 is the master, not Prox1. Not sure why that is. It doesn't matter. All right. So, question is, how do we determine whether our high availability is working? Well, if I ping server 1 on a recursive ping, as you can see here, and then I disconnect the Ethernet connection to Prox1, then what should happen is the server will disappear off the network, and as a result, so will the virtual machine, and then it will spin up on another machine. We can see here that the high availability job is running, telling me what node it's running on. So let's give that a shot. So now my network is disconnected. We see that the request is timed out. I'll just speed this up a little bit so that you can see the process happening without having to wait. Okay, so that took about 2.5 minutes. So we can see that it's spun up, it's starting the machine, it's decided that Prox1 is dead, now Prox2 is active, and there we go. Now if I go to my Pi-hole server and refresh the page, there it is, all working again. Fantastic. So that all worked very well. There you go. So that's how high availability works. Next we will install Home Assistant and get it up and running. Okay, so now our system is all back to normal. We're going to install Home Assistant, build Home Assistant based on the instructions provided by Whiskers in the tutorial that you would have seen on Dr. Z's screencast some time ago. So, but there's a slight change to the settings. That's because the original process that Whiskers published, Home Assistant has changed the deployment approach using a different compression system. So we're using a different sort of scripting approach, but let's get on with it. First thing we do, we go to our to whichever node we want. In this case, again, I'm going with Prox1. Go into shell, and then we issue this wget command, and it will run off and grab the install script from Whiskers' GitHub page. Now we need to install unzip. Now, if you've already done this, you won't need to do this again. This is the first time I'm installing this this Home Assistant on this machine, so I've installed unzip. Next, we will make a change to the script to replace the original gunzip with zip. That didn't take long. Now we are going to move the temp script across to replace install, change the permissions, and then lastly run the installer. Then it will ask you where you want to put the machine. I'm going to use my data pool, and this will run off and do its thing. It won't take very long, maybe 30-40 seconds. Probably by the time I've finished talking at the speed it's going, it will have built our VM for Home Assistant. It actually takes longer to get the machine up and running and deployed than it does to build it. All right, I'm just going to pause the video until it's completed. Okay, so that's now completed. A few things I want to do before I spin the machine up. First thing I want to do is add a serial port. This is so that I can change the terminal emulation on my screen. So that's correct. The other thing I'm going to do is edit the size of this machine. To do that, we need to put in the correct number of megabytes. That's correct. I'm also going to beef up the number of sockets, etc. Number of cores. I'm going to give it 4 cores. My Home Assistant setup is quite beefy, I should say. All right, that's pretty much it for now. So we've got that set up. So let's start the machine. Once the machine has decompressed and finished building, we will actually change the size of the hard drive. So we can see that that's started up. All right, It's booting up. It's given itself an IP address. So what I want to do now is I want to change one of the settings within the command line. Hopefully it's finished booting up. Takes a minute or two when you first install Home Assistant. Log in. No, that's the wrong username. To be root. That's it. Now I put in this command, and what this does is changes the way the console works to enable us to do copy and paste, although technically we just did a copy and paste, so I'm not sure what difference that makes. But anyway, it's a step that Whiskers suggests doing. So what I'm going to do now is I'm going to change the IP address of this machine to the next available, which is 9. So we grab this command off my web page, paste that in, hit enter, and that's done that, and then we commit the change. That's it. Connection successfully activated. Okay, so if I go back to the summary page, or I might have to reboot the machine. If I reboot the machine, then it should take the new IP address. Oh no, there it is. I don't need to reboot it. It has changed the IP address. All right, so if I now try to log in to this machine, it probably won't work because it's not finished booting up, but we can give it a shot. 10.110.10.9 8123. There we go. So Home Assistant has successfully been deployed and installed. Now that we have Home Assistant all up and running, and we've also got Pi-hole up and running, what I need to do is the last steps in this tutorial, which is to make Home Assistant highly available. Now, we've already done this before with Pi-hole, but the process is exactly the same for Home Assistant. So we just go on to the virtual machine, then we select Replication, hit Add, and then give it a replication partner or target. Now, as I said before, it's pretty important that you consider how often you want the replication job to be done. Now, when I started thinking about this, I thought, okay, so if I make this happen every 15 minutes, let me just show you. I've since installed all my settings on Home Assistant. So as you can see there, my Home Assistant machine is a 4 CPU core, and it's running 8 gig of RAM on a 60 gig hard drive. And when at certain times of the day, it gets quite busy, particularly when my kids are out watching TV or doing whatever they're doing, and they're switching things on and off and stuff like that, or the watering system comes on, or the spa starts doing its thing. There can be a lot of traffic, so that's why I've made my machine quite big for a Home Assistant implementation. Now, therefore, when I'm running replication, I have to consider, okay, they're all of my machines only have 1 NIC in them. I'm trying to replicate Pi-hole as well. It's a small machine, but Home Assistant is going to use a lot more resources. And considering the alternative, that is no clustering, no high availability, which means that if my Home Assistant instance, which was sitting on a Raspberry Pi, had an SD card failure, then it would take me probably an hour to recover, because I'd have to reinstall Home Assistant, grab the last image that was backed up online, download that, then deploy that onto the machine. So you're over, you could be up to 12 or 13 hours, depending on how often you set your snapshots, behind anyway. So are you really missing anything if you set it to be every, 2 hours, for example, or even every day? So just consider that. It's not like, a server application where you're constantly writing, got lots of people constantly writing data to files and things like that. Sure, Home Assistant does do that. It writes things to databases, of course, but is that information, unless you're doing any sort of data science work on the stuff that you're capturing, then do you really need to have it so close to real time? So in my case, after thinking about all that and saying all that, I'm going to set mine to 2 hours, hit create, then I'll press schedule job now. And while I'm waiting, I will do the same thing again to Prox3, and again every 2 hours, hit create, and again schedule now. Now you can see here that it started doing the schedule. You'll notice that this job has failed. That's ironic because what I was just talking about actually has happened. So let me explain. So when I go into my Pi-hole setup here, I had the replication job between Prox2 and Prox1 every 15 minutes. Now I've changed that to every 30 minutes. And as it happened, when I was setting up the replication job here, the replication job on Prox2 was already running. So this one failed, because you can see here there's no machines running on Prox3, so the replication job worked completely fine. Now, I've decided to remove this job and I'll reschedule it. I won't wait, make you guys sit through that, but just to sort of let you know that the exact scenario I was describing before I set up the schedule happened, where we had a bandwidth error. So if you're building your if you're building your replications and you experience the same kind of error, that's all you need to worry about, is just make sure that any other replication jobs you're running on that target server, that they have finished their work, and then if you hit schedule again, it should come good. All right, so moving on from that, the next thing we need to do is set up high availability. So all we need to do there is go to our data center, hit HA, hit add, then we select the VM, which is that one, the one we're going to monitor, and that's pretty much it. We don't need to do anything else. Hit add, and this will start. Now, something else is starting. So something else I just wanted to show you. I probably won't be able to do this, but if you want to migrate, say for example, for maintenance purposes, you want to, pull node 1 down to add more RAM to it or something, or maybe add an extra hard drive, whatever the case might be. So you want to move whatever machines that are sitting on this node onto another node. So what you can do is you can hit migrate, and then you can tell it where you want it to go. Now you can see here straight away, it's saying I can't do Prox2 because there's an issue with the disk. But if I choose Prox3, I should be able to do it, even though the message isn't clearing. I know that will work because I've done it many times already. But that's how you can move your machines around between your nodes. I just realized the reason it's giving that error is because it hasn't finished synchronizing. So the point is, though, replication has to be running in order for this migration to work. To explain what I mean, if I go on here and hit migrate and move this to Prox1, if I hit migrate, it will work. So there's no errors because all the synchronization is all up to date. So so just be careful, just be aware that in order for migration to work, you have to make sure that the replication jobs are done, because it's going to use those replication paths to build out the machine on the other node. Okay, so that's it. Thank you. And please like, share, and review. Subscribe to my channel. I will be making more videos and hopefully becoming a little bit more sophisticated, starting to play around with some music and other things like that. If you've got some suggestions of things that you would like me to maybe make some videos, please do. Keep in mind, there's lots of people out there making videos on Home Assistant, and some of them are varying degrees of quality. Where I want to see my niche target is explaining things that are perhaps a little more challenging to do in a way that is, I hope, a little more user-friendly than average. So I can't guarantee that even if you make a suggestion that I'm going to be able to do it, but I'll give it a crack. I do plan at some point to make another video on how to potentially use the wireless interface on these devices as a way of using that as a replication channel. You can't use it to support machines. It won't work. We can't bridge them, but it might allow us to do a replication job. I'll just have to see how that works. Anyway, if that happens, who knows when that'll be, but watch this space. So, okay, thanks. Signing off. Goodbye.